Good afternoon, everyone. Thank you. Thank you very much for joining us in today's webinar on Rtds for Substation Automation System. My name is Firas Hamdan and I work in the commercial department in ZIV. Today evening is a part of ZIV 2025 training plan, which include free online session like this one, held on the third and fourth Thursday of each month, as well as paid in-person training session under the program ZIV University, which we will organize it in Bilbao and Barcelona. You can find all the details about our training program on our website www.zivautomation.com. Today's session will last total of 30 minutes, with 20 minutes dedicated to the topic presentation and the remaining 10 minutes for valuable question and clarification. You are kindly requested to click on the display button and select the full screen option for a better viewing experience, and to send us also any question you may have during the presentation via the chat feature inside this webinar. Now, I am pleased to introduce my colleague, Oscar Pereira. He is Sales and Application Manager, and he will lead this presentation of today. Oscar, the mic is yours, please.
Okay, thank you, Firas, and good afternoon to everybody. Again, thank you for joining us today to this interesting session, to this webinar. I will be sharing with you the main use that we do in ZIV of the power system simulators. So hopefully you will find our uses interesting, and perhaps we can be of help for you with any issue or question that you may have. So first thing, well, this is the index. I want to share with you the main points today. Well, I will start just by saying some general things about the hardware in the loop simulation. But more than that, I will go directly to explain you about the power system simulator and the two main applications that we perform in ZIV, related to protection relays, that is our core business, as you very well know, and also to the digital substations. And we will finalize the session with the benefits that we obtain from the use of these kind of simulators. So let's start very quickly with some general ideas about the hardware in loop simulation. As you can see in the diagram there, well, it's so simple as to have in a closed loop the IED that you want to test, the test equipment itself, and a set of software routines running in a computer, and all those elements, as I said, in a closed loop interacting each other. So this scheme, this approach in our energy business, in our energy sector, how is it applied? Well, the thing is that our test equipment will be a powerful equipment with the capability of simulate the power system. So, in other words, our simulator will be replacing the real electrical network, will simulate the power transformers, the overheat lines, all the elements in the system, and that simulation will be interacting directly with in this case, with our protection relay. So it's like we will be able to perform a complete test, complete set of tests that from a quantity point of view, we will be able to execute thousands of possible scenarios and faults and whatever, that otherwise it would be really difficult to perform those on the site. And also, even more than that, we will be able to test our physical relay in coordination with, let's say, other relays that we can as well emulate in the simulator. So remember, we will be performing tests by simulating the electrical network, the power system. We will be able to replicate or to emulate thousands of scenarios, different kind of faults, and even we will have the ability to see how our relay behaves together with other elements that we will be emulating. Of course, having said that, as you can very easily imagine, the quality of the simulation software that you use will be the key point for you to obtain a valuable testing or not. And here is when I have to introduce you, probably some of you already know, the Rtds power system simulator. So Rtds is a private company that, well, in many years ago, in 1989, they launched to the market the first fully digital real-time power system simulator. Since then till now, this simulator, commonly we call them the Rtds simulator, so we take the name from the company for referring to this software simulator. So during those years, it's like they became a kind of world standard. Nowadays, this simulator is used in more than 40 countries. And and in fact, in ZIB, we are one of the manufacturers that have adopted such simulator for our internal testing and for support customers, for example, like you, hopefully. So on the slide, you can see mainly the 4 types of users of this power system simulator. As I said, the equipment manufacturers, the OEMs as we are, but also the electrical utilities. Those are great users of a power simulator. Also universities, research institutions for their R&D projects, etc., and also consultants. All these kind of agents in the market are users of, or are potential users of such a power system simulator. So again, as I mentioned at the beginning, what the Rtds simulator does is to emulate, in our case, electromagnetic transit simulations. So in other words, we will be able to simulate faults in our laboratory. Not only faults. Faults are nothing if you don't simulate at the same time the network itself. So again, this simulator will be able to create virtually large and complex networks that will be operating in real time with the simulation, with the transits that are simulated. So as you can see, this approach to the testing is really something very new, let's say, that has changed the way of working and testing that was done in the previous years. So very clearly, and which are the uses that ZIB does of this Rtds simulator? Mainly 2 uses. We use in the area of the protection systems, so the relays, and in the area of the substation, of the digital substation as a whole. Those are the 2 main uses that we do from this power simulator. The first one, the one that you have now in the picture. Regarding the protection relays, one of the typical use of a power simulator is to evaluate the new algorithm that, for example, we as manufacturers have designed. So imagine if we are working on a new relay that will be launched to the market in the coming months. The Rtds simulator has been proven a very useful tool to test any new algorithm in the relays. So for manufacturers like ZIB, this is very important. But also think on this other point. It could very well happen that electrical utilities are ready to open the door to new vendors, to new suppliers, but they could be not very confident on those new relays. So again, the Rtds shows as a useful tool to test relays of what I mentioned there, of the newcomers to the utility, right? So in fact, more and more frequently when ZIB approaches new markets, we find utilities that require from us to show how our relays behave under an Rtds simulation, right? So this is talking about the checking of the algorithms to validate a new vendor, but also there is a second point, the B point mentioned there, that is perhaps it's even more common for us, that has to be with the incident analysis. As you very well know, quite often it happens that there is an incident, a fault in the system. The relay may operate or not, but at the end of the day, the utility wants to know what happened, what were the effects of that fault, if the relay tripped correctly or not, etc. So again, this Rtds simulator is very useful to repeat again in the laboratory what happened days ago on site in the field. So this is very useful, for example, when there was an incident, imagine, and at the first point, maybe the utility understood that the relay didn't behave correctly. So at that point, for example, what we do is we ask the utility for the settings of the relay. So we ask the utility for the data to modelize, to virtualize the network, and with the oscillos that the utility recorded in the real fault, we repeat again the situation in the laboratory, and we will be able to determine whether the relay tripped correctly or not, or due to which reasons the delay was bigger than expected, etc. So just remember these two main points that we focus on regarding the relays: the switchability of new algorithms, and to validate the behavior of the relays under an incident situation. Now I will show you just two real examples. For example, when we have to validate new algorithms in ZIB, for example, this showing now on the screen refers to the validation of a transformer differential relay. So in this case, my colleagues, our expert application engineers, they modelized that grid that you see in blue color in the Rtds simulator. So they emulate two bus bars, 500 kV, 150 kV, with two lines, with a three-winding transformer, etc. So once that the grid is modeled in the simulator, then the next step is to decide where, at which points you want to simulate faults. Look there in red color. In this test, we decided to stress our transformer differential relay with 7 different kind of faults: internal faults in the transformer, external faults, faults in the busbar, etc. And again, with the arrangement that I showed you in the first slides, with a computer running the simulator and the simulator interacting in the relay, we will be able to check the behavior of our transformer differential relay in this case of different kind of faults in this kind of electrical network. Same like this, for example, another example for a line differential relay. Here you can see easily two relays, A and B, at the bottom of the picture, and two 500 kV lines, two parallel lines. Again, to validate the behavior of a couple of line differential relays, each one at each end of the line, we are stressing the relays with faults shown in the picture in blue and red color, faults in the bus bars, faults in one of the line, in the other parallel line, at different distances from one bus bar to the other. And this is a way also by, let's say, by performing this set of tests, we will determine if the behavior of our differential relay is acceptable or not. This is a scheme of what we prepare for this in our laboratory. You can see the closed loop that I mentioned at the beginning, the hardware in the loop. So you can see how there is a physical connection between the transformer relay in the gray box with the Rtds simulator. As you can see, the Rtds simulator, those blue cabinets are in connection with a computer that is sending the information of signals and so on. And the blue panels are in charge of transmitting to the relay the currents and voltages that simulate the fault, the transients. So, and in the PC shown on the right side of the picture is where, in our case, ZIB, we will be recording all the events, oscillos, and in other words, all the behavior of our relay. This is a real picture. The quality is not that good, but in any case, it's just to show you a real arrangement in our laboratory that shows on the left side the Rtds simulator, in the middle of the picture our relays and under testing, and on the right side the so-called amplifiers that they are just the ones, the injection machines, are the injection kits in charge of connecting with the relay and injecting currents and voltages. Well, and finally, or the second main application, all that I explained so far was related to the protection relays. But if we go one step higher, let's think on the digital substation, on the substation as a whole. Here, we have two main uses. First one, in some cases, you need to test your relay, but under a very complex layout that is difficult to go to the field for that. For example, one very clear example is, imagine an automatic voltage regulator, an AVR for transformers. You want to validate the behavior of your AVR for a situation of 5 power transformers working in parallel. This is not that easy to make those tests in real on the site. So for that, this Rtds power simulator is very useful. We can virtually create or emulate 5 power transformers in our system, even being the same, the 5 equal or different. We can, of course, include in the hardware in the loop our physical AVR, and we can test the behavior of our AVR in a situation working with 5 transformers in parallel, with no need to go to the site and to stress the machines, right? And another approach talking about the substation, not just the relay, but the substation, is all that has to be with the communications. As you know, nowadays the communications have become also a critical point in your substation. So the Rtds simulator gives you also the opportunity to test in your laboratory which is the behavior of a relay under conditions like loss of packets, of loss of informations, under the loss of a synchronization, or some delays in the communication. So again, you can see how robust is your design, is your relay under some issues with the communications. So having said that, just I put here some benefits. You can check them later on. But mainly, as I was mentioning, the use of a real-time power system simulator gives you information on which is the performance of the relay and which is the dynamic response of the system. It's good to validate algorithms for incident analysis. Usually it's a must for new vendors trying to enter into a new utility. Sometimes we as a manufacturers, we use during our factory testing, etc. So again, now it's a question of you to identify if during your daily job you might enjoy of some of the uses of this Rtds system. In that case, we will be glad to discuss with you how ZIB and our Rtds can help you for any validation or to help you with an incident analysis, or if you want to check the effects of problems with the communications in relays, etc. So I think that this is all that I have prepared for today. So at this point, my friend Firas, I am ready for any question or clarification that we may have.
Thank you, Oscar. Thank you very much for your efforts for this valuable presentation. So we have one question from Mr. Sudir. Thank you very much, Mr. Sudir, for your participation. So the question said, do we build our model with parameters for each transformer from the actual vendor, or it is from our library?
Excuse me, Firas, you say, do we?
Yes, because I rephrased the question. So the question says exactly, do you build your model with parameters for each transformer from the actual vendor, or is it from your library? It means from our library.
Okay, we build from our library when we are validating the algorithms and so on. But for example, when we have to go for a specific incident analysis, we build with the parameters of the manufacturer. For example, maybe a couple of years ago, during a commissioning, our commissioning engineers were facing a lot of problems with a transformer, with a transformer differential that was tripling, and so on. So, well, making the story short, at the end of the day, we came home, we came back to factory with the parameters that at that time the manufacturer of the transformer was Faramax. So we built the model of the transformer with the parameters given by Faramax. The customer, the utility, gave us the settings to modelize the network. And okay, at the end of the day, we came to the conclusion that the problem for the tripping of the relay and so on was that in one of the poles, in the phase A or something like that, of the secondary of the transformer, the polarity was changed. And that was very useful to determine that, okay, the problem was not on our side, was not with the relay, but was with the wrong connection in one of the poles of the transformer. So, I mean, for that particular case, we had to modelize exactly the transformer as was given by the manufacturer.
Good. Thank you, Oscar, for sharing this case, which happened with us in the past. It will be, I think, very fruitful for our guests. I think there is another question coming, so maybe we can wait for some seconds.
Okay. Okay. Well, in the meantime,
yes, please.
Okay. No, I just want to, we give some time if somebody else want to make some questions. Okay. Otherwise, just let me just send you a couple of messages. Just in 1 week time, next Thursday, 27, at the same time like today. In this case, our colleague, another colleague, our application engineer, I think Alberto, will be presenting a seminar on distance protections applicable to medium voltage distribution lines. This is a hot and quite interesting topic because usually the distance protections are thought to be applied to high voltage lines, but the same distance protection, the same schemes can be applied to medium voltage distribution feeders. So I encourage you to join this interesting webinar just in 1 week. And second message, if you don't mind, also keep in mind that we will be organizing an in-person training in Barcelona on teleprotection systems. So for all of you that are dealing with teleprotections, with power line carrier, with networking, all that scope of the comms and high voltage communications, probably this seminar could be of your interest. In any case, all the data of this in-person seminar to be held in Barcelona, as well as all the webinars, as this one that I mentioned before, all the information is in our website, so you can check whenever you want. And
thank you, Oscar. We had another question, if you don't mind. So the question says that do you see any concern in connecting solar panels to the grid system in terms of fault levels?
Well, in theory, not so many concerns. In fact, one of the applications, but I didn't mention today because it could be too much, but one of the concerns that the Rtds simulator also of the applications that is offered is to see in particular what you mentioned, the connection of solar panels to the grid and how this is the impacts on the stability of the network. So concern not, I mean, there are many installations operating in the world, in our country, in Spain, a lot. So, but it's true that the Rtds simulator is also a key tool for that. But honestly, all the applications and uses that we are doing so far are more related in the field of the protections relays and on the substation automation. We are not using so far for the solar panels in the microgrids, or we are not using with DC systems. The possibility is there, but we are not using so far those applications in ZIV.
Thank you, Oscar. We had only 1 minute left, so we will take just one other question very quickly. So the question says, is there any available fault simulation concerns solar base feed into the grid model?
I think that the question seems to be quite similar to the previous one. Again, we have no concern on that. It's true that our experience is not so big as simulating faults with relays or with substations, but in any case, the studies that we performed so far and the limited approach that we did to the solar panels and the grids didn't show to us any kind of concern. We were able, in all cases, to simulate the network, the panels, and so in the same way as we are doing when dealing with relays.
Thank you, Oscar. Thank you very much for your answer. Sadly, the time had finished now. We need to finalize this webinar. Again, I would like to sincerely thank all our guests for joining us. We really appreciate your engagement, your fruitful question. We hope that you find this session very informative and very inspiring. For sure, if you have any follow-up question or any feedback, feel free to reach us out via our website or any contact you may have in ZIV. We are here to serve you. Thank you again, and we are looking forward to seeing you at our next webinar, which will be, again, let's insist on next Thursday, the 20th of March. And it will be on the application of distance protection of medium voltage distribution. So once again, thank you very much. We look forward to see you in the next webinar. We already shared in the chat a link to download this presentation and also some other link informative for the remaining program of ZIV training. Thank you very much and see you soon.
Thank you.